Can you hear me well? Hello everyone, I'm Pavel. So I'm very happy to be here. I came quite a long way from London, and so I'm really impressed by this place. And for me, it's very first trip to South America, and I'm very happy to be here. So what I'm doing in my presentation, I will talk about way how you can actually fight DDoS attacks with open source tool without paying anything, without any commercial contracts, and by just using tool. So during course of my career, I managed to work to basically all aspects of internet life. I worked for domain name registrar, I worked for hosting provider, I worked for internet exchange points, and finally I worked for a global security company. And by the way, it was Cloudflare. So for now, I'm Chief Technical Officer and co-founder of a company called Fastnetmon, and I will tell you about our offering. So what is Fastnetmon? So Fastnetmon is a software, and it's on-premise software which can be installed on Linux machine. This software is licensed under terms of open source license called GPL2, and Fastnetmon can help you to identify a target of DDoS attack in your network, and it will help you to automate ways to stop this attack. And I will tell you how later. So when we start talking about DDoS attacks, there are plenty of types of DDoS attacks, and there are basically thousands of companies fighting some kind of DDoS attacks. In scope of Fastnetmon, we work only for attacks which pose real danger for service providers, companies like you represent. It's attacks of scale of tens gigabits, hundreds gigabits, terabits. And in majority of cases, those attacks are made by leveraging of L4 and L3 levels of OSI model. So on this slide, we can look. So basic every single field in IPv4 packet can be randomized and used for DDoS attack. In IPv6, we have slightly less fields, but again, every single field can be randomized and sent to our backbone infrastructure, so basically for reason to overload it somehow. So every single field can be randomized here. And from layer 4, basically we speak only about TCP protocol. And in this case, we have few more fields, and again, every single field can be randomized and used to generate malicious traffic. And those levels of are only ones which we care at Fastnetmon. Why? You may ask why we are not talking about L7 attacks, because we don't know from network perspective, because from perspective of routing backbone, we have no idea what's inside. We know source IP, we know source port, we know destination, but what's inside, we don't know. And that's the reason why it's explicitly out of scope for Fastnetmon. Fastnetmon is here to help you to defend your network. If attack is against your application, you need something else. So usually, those attacks I explained. So again, I don't like terminology about naming DDoS attack, because plenty of companies name attacks because after themselves. Basically, I would say, and I would focus on those attack types. It's TCP attack, TCP floods, UDP floods, GRE floods, lots of types of amplification attacks, and spoofed attack types. Only those attacks, they pose real danger for your attack. And I would say it's not important how it's called. All those attacks implemented by some kind of variation or randomization of fields available on packets on levels 4 and levels 3. So what about weather, about DDoS attacks? Why I call it weather? Because it's absolutely unpredictable. We cannot tell for sure by having any kind of intelligence how many DDoS attacks we will have in this specific region. Will I have DDoS attack next week? Will you have a DDoS attack next week? It's unclear, because there are hundreds of thousands of variables in this equation, because it depends on activity of law enforcement. It depends on financial regulation and level of scrutiny made by financial institution in attempt to find out source of money used for example, for extortion. It's basically depends on where if bad guys decided to just walk up and start attack or not. So we cannot make any expectation about future. But those numbers on left side, they can be provided by Dutch non-for-profit association. It's called NBIP Nevas. And they show us that those attacks are on rise, they are very high and very dangerous, and peak level of, like you can see, we have lots of attacks. And still, great side, again, volumetric attacks, and which have main target to just fill bandwidth available for your company, are still very dumb. That's very great news for us, because again, not so much you can do if you want to generate huge amount of traffic, like hundreds of gigabits, and still in top it's DNS amplification and Memcache amplification, NTP amplification. Those attacks are here for more than, I would say, 8 years, and unfortunately they will stay for way longer. So because at Fastnetmon we have huge user base. I would like to highlight this. I talk about users. It's not people who actually pay for our product, people who actually use our product. We have access to lots of different vendors, models of equipment, and basically it's just list of a few fancy vendors, but I can assure you, in 99 cases, your vendor will be supported by Fastnetmon, because somebody else sent us pickup DMs, found out some issues, and we introduced support for it, for product. And in terms of our deployments for Fastnetmon, Fastnetmon X project exists from 2013. And we have customers on all continents, unfortunately with one exception. And you can see it's evenly distributed. And we have lots of customers in Europe, Latin America, in the United States, in Asian Pacific region. And in terms of features of Fastnetmon, if I'm here to sell product for you, because again, it's free product, I'm not going to sell it, but I want you to use this product in your network. What I can tell you first, it's easy to install. It's not cranky install tool, you need to find out guide somewhere with out-of-date configuration, with out-of-date documentation. Fastnetmon is really easy to install, because we spent basically a decade to polish every single step of installation, configuration, every single aspect of compatibility with equipment. And basically, we had lots of bugs discovered over the course of last 10 years. Unfortunately, majority of them were discovered before you, fixed by us, and now available in product and completely for free. And second thing is, Fastnetmon is very predictable. It's not black box. It's not some, for example, if Fastnetmon detected attack, you know for sure why. It's not about it's randomly pick it up as DDoS attack. No. You will know for sure why it happened and what was reason of it. And in terms of different distributions, on early stages of project, we had some preferences. I would be honest with you. We supported only Debian. But with time we learned that different companies, different industries, they have different preferences, and it's not up to us to make decision. That's why we support all of them. So, and thing is, which makes me very proud, not only for myself, but also for community, because it's not made by Fastnetmon Limited, it's not made by me, it's made by community. It's effort of at least dozens of people working for introducing Fastnetmon into official distribution trees of every single distribution you can see here. So if you have stable version of Ubuntu, or Debian, or Red Hat Linux with Apple distribution, you can just pull your name of your package manager, install, and you will get Fastnetmon. So again, it may sound as overkill, but again, let's imagine we face DDoS in an unexpected time. It's middle of night. It's cold. You had fever. You woke up. You have no idea what's going on. It may be fire alarm in data center. It may be flooding. It may be optical cable cut. And you know, and you haven't slept for like 12 hours or maybe 12 days. you need to find out what's going on, and every second save it on downloading tool or installing tool is important. That's why we polished it to perfection. So, of course, Fastnetmon is not extremely actively developing tool. It's not something you will download it to tomorrow, it will be completely different. But still, from time to time, we introduce new capabilities, we add new support for new vendors, and if you want to install latest version, we still have option to do so. And one of the things which is, I would say, one of the game changers for Fastnetmon, we are obsessed with detection time for DDoS attacks. And we support all the state-of-the-art traffic telemetry protocols, such as IPFix 315 from Cisco, or inline monitoring services from Juniper, or Nokia SIM from Nokia SR platform, just to get detection attack time faster. And right now, we can offer detection in 2 seconds, and in some deployments for 1 second. Because why it's important? Because DDoS attacks get escalated and get faster with every single month. I remember when actually first version of Fastnetmon was released, to get 10 gigabit DDoS attack from the beginning to actually time when it actually gets speed of 10 gigabits, you need to wait for 15-20 minutes, because you can see on graph list 100 megabits, 200, slowly growing, but right now it's 10 gigabits. 100 gigabits, 400 gigabits. And even if you're a huge operator with great regional connectivity and international one, it's important for you to cut it as soon as you can. Otherwise, your customer will notice it, and it's not great. In terms of ways how Fastnetmon can learn and get traffic from your network, basically, we support all the telemetry protocols available on market, maybe with some few exceptions. It's up to you to decide which one is the best for you. From my personal taste, S-Flow or inline monitoring services on Juniper platform are best protocols for DDoS detection. But again, it's not by us to decide. If you already have some traffic telemetry, let's use it, and Fastnetmon will handle it very well. And again, names of detected attacks exactly match vectors of attack. I explained it on at the beginning of presentation. And in terms of scalability, those numbers are very shy, because it's not easy to get from companies like formal approval to publish their success story and publish their bandwidth numbers, because not so many people actually like to expose what kind of protections they have. And that's why those numbers, I can be honest, some of them 7-year-old. So from perspective of Fastnetmon, we can do way better. And you may have somebody from a room may have better numbers. If you can, please tell me. I will update those numbers because they are very old. And again, because Fastnetmon is implemented in C++, and every single time, like every few years, C++, our committee, they release new version of C++, which gets slightly better. And basically, we just, most of the time, we just sit and doing nothing and wait for new version to get faster. And automatically, Fastnetmon also get faster with every single time when you update Ubuntu, for example, when new version gets released. So what Fastnetmon can do? My original background is software engineering. What was BGP or NetFlow or IPFix? I learned just 10 years ago. I had no idea what is it. But what I learned, it's a language network engineers used to talk with each other. And that's why initially in Fastnetmon, we also only had support for script callbacks when we detect attacks. But then what we learned is that we need to speak language, which is basically used by network equipment to interact. And that's why in Fastnetmon, we have native support for BGP protocol. It's not like callback. Basically, we have full implementation of BGP protocol for crafting and parsing for unicast and BGP flow spec. And it basically battle tested with all the major equipment, so you can create annonces directly from Fastnetmon. When Fastnetmon detects attack, it can inject specific community, set specific next hop, and provide all kind, and set, of course, assign as much as needed community for you, just for traffic engineering. So, if you don't care about DDoS, we have lots of nice graphs in Fastnetmon. If you don't expect to get DDoS, those graphs, they have great advantage. In compare with many tools for network visibility on market, those graphs are hard real time. So basically, you can see updates of every second. This graph is not exciting, again, because it's total outgoing and incoming bandwidth. It can be done by SNMP. This one is more interesting. This one is basically this logical distribution on different networks. You can see bandwidth for network on logical base, not on level of ports or specific links, but on level of specific services which use it. And again, there are options to get more detailed view for up to host. And in terms of deployment of Fastnetmon, again, as we put lots of effort to making very fast, you can run it on virtual machines starting for like few gigabytes of memory and basically 1 or 2 CPU cores, and it will work just fine. If your network is no more than 10G, you can run it on Raspberry Pi if you want. And actually, we have support for ARM platform, and we have multiple customers using Fastnetmon on Raspberry Pi, because again, if for small networks, it works just fine. And how Fastnetmon works from DDoS detection perspective. This is a very important topic, because expectation what is DDoS attack is differs for different people. And from our side, I can tell you following. Fastnetmon, unfortunately, has no capability to tell is it DDoS or not. Why? What we can see is that specific type of traffic, for example, for specific IP in our network, we receive more than 500 megabits of UDP traffic. Is it DDoS or not? We don't know. It's your responsibility to set baseline and tell their Fastnetmon, if amount of UDP traffic for this host exceeds 100 megabits, it is DDoS. If total amount of traffic exceeds 10 gigabits, it is DDoS. And that's exactly how Fastnetmon works. From this perspective, you can look on Fastnetmon not as magical DDoS detection tool, but more as a reactive network automation, which responds not to change in configuration, but instead it reflects, like it actions when amount of traffic or amount of bandwidth changes. Some specific network got too much traffic, something wrong. This specific host, which usually no more than 100 megabits, got 100 gigabits, it's wrong. And then when it happens, Fastnetmon can call script and pass lots of information for your systems, for network management solutions, alerting systems, or Fastnetmon can create BGP announce. And what happens next? It's more up to your routing policy to decide. Majority of cases and majority of deployments of Fastnetmon, they deploy it for two purposes. One of them, which is, I would say 70% of deployments, is a automated BGP black hole to basically stop all the traffic coming to specific host on your network. I would have to repeat it. And in this case, we basically unplug service which under attack. It may sound, I would say, very harsh, but we are here not to save end service. We're here to maintain availability of network and then decide what to do with this specific service. And in this case, Fastnetmon just creates, in case when it detects attack, it creates BGP announce with specific community, again, standardized as 666, and we propagate this information to your backbone, your router start dropping traffic, and then they propagate it to upstreams, and upstream start dropping all the traffic. Second most popular deployment option for Fastnetmon, it's in combination with cloud-based scrubbing centers. Because in this case, if you have subscription for cloud scrubbing centers, it can be any company. We have no preferences about which company you use, because again, we believe that instead of offering all the things from our company, we believe that customers need to pick up best solutions they have, because there are no best scrubbing center. And because it depends on region, it depends on purposes, it depends on industry, it depends on budget. And that's why we just provide option for customers to use Fastnetmon to move traffic away from your network. But difference in comparison with automated BGP black hole mode, in this case, Fastnetmon can identify into which network, usually it's /24, host under attack belongs, and then make more specific BGP announcement to scribing center. And by doing so, to move traffic away from your normal path and restore your normal network operations. And to set baselines, basically to explain to Fastnetmon what is the normal and what is not, we offer multiple options. So it's basically it's 3 types of thresholds. First type is number of megabits per second for specific IP, number of packets per second, that's packet-based attack, and number of flows per second. And again, we also provide option to set those baselines on level of all the protocols for UDP, TCP, and ICMP independently. And in addition to working with all the BGP implementation from all the major vendors, we also have support for scribing boxes. So we have very solid integration with A10 networks and Radware. And if you have enough capacity in your network, or you have custom-made infrastructure for actually scribing center in traffic in your own network, you still can benefit from Fastnetmon for purpose of moving traffic away from your normal path to specifically allocated infrastructure, which are basically built to receive the DDoS attacks and filter them out. So in case of black hole automation, it works following way. So you need to send information about traffic called network traffic telemetry from your switches or routers to Fastnetmon. You need to establish BGP session with Fastnetmon, and then when Fastnetmon can notice that specific host exceeds bandwidth which you set in configuration as normal. For example, you set everything below 1G is fine. It may be, for example, your plan for you sell to customers. And then if it exceeds, then something going wrong. And then in this case, Fastnetmon will create BGP announce, send it to your router, and then they will propagate them to their upstreams and basically eliminate malicious traffic from your network. So for cloud scribing centers, it's more, I would say, flexible, but in this case, instead of completely blocking traffic, we just move it away out of the boundaries of our network. And when Fastnetmon detects attack, it provides lots of different metrics. What is the source? Like, we don't provide information actually about source, because it's a very common question. What is the option to find out source of DDoS attack? Real DDoS attacks, which I mean by real DDoS attack, I am talking about at least 10 gigabits of malicious traffic. They're not coming from some source. Usually it's hundreds, thousands, 10,000 of sources. Majority of them are fake. We cannot block them one by one. But even if we can, traffic is already here and our bandwidth is already saturated. Even if we block it, it doesn't change anything. And that's why Fastnetmon is not focused on blocking remote attackers. It's focused on finding out what is the victim in our network and blocking it. And you can see there are lots of numbers, and all this information can be passed to scripts. You can make decisions, for example, if it's UDP, make custom actions, or just provide nice email and notify your client or your network team. And the best part of it, you can use script callback. And instead of using our BGP implementation, you can, for example, make some changes on your routers. For example, make renumbering for port translation pools and exclude IP which is under attack from rotation, just to eliminate impact, and lots of options. Basically, it's just it may be Bash, it may be Python, it may be Perl, it may be Go. So it's up to you on which language you use this. You just pass information about attack to script, and then you decide what to do with it. And so that's all. And basically, Fastnetmon was built with great contribution of community. We never actually had a roadmap. It was the very first time when I did something which resembled Fastnetmon. I got lots of basically thousands of emails with some kind of proposals, ideas, cases, and that's how we built Fastnetmon in the way how it is now. So, and you have great deal of power to influence it if you can share your story, if you have any questions to me, and if you have any proposals. And again, code is open. And if you feel comfortable with programming or just looking for source code or you want to understand how it works, you can do it. And all the time I'm very happy to talk about Fastnetmon in general, traffic telemetry protocols, BGP implementation, and BGP flow spec implementation in particular. And in addition to my personal contacts, we have great community. It's actually a fancy one. Because again, we tried, it's exactly the same story as we did with Linux. Instead of trying to find out what is better, is it Slack or Discord or Telegram or IRC, we combined all of them together just to stop fight in community. And right now, it's a large community of almost 2,000 engineers, mostly interested in networks and network security. And basically all those people, they distributed over the planet. And if you have any questions, then feel free to join and ask people. I would say it may be actually one of the world's largest communities about DDoS attacks. And lots of people are very helpful and they can share their stories. And if you have particular questions which are specific to region, you may be quite lucky to find out answer here. And thank you for listening, and I will be happy to answer questions.
Okay. Muchas gracias, Pavel. ¿Alguna consulta? Questions? No questions?
That's a beer time. Thank you for coming.
Thanks a lot, Pavel.